All right, so we're going to go over some wiring today. I've had a lot of questions, a lot of people having issues with a lot of these ESCs that run a series connection like this. Um, Especially a lot of the newer ones, they're coming with the series connection hardwired. As you see here, it's directly connected to the board. Some of the older ones, these wires would, let's make this disappear, come together like this into a plug. We'd have a plug here, say like that, and then you'd get a series harness or a parallel harness, and you would plug them together. So you'd have a break between. Now they're hardwired, so you can't plug anything in between. Makes things a little bit more difficult when it comes to these direct power servos and getting connections put on them properly. The confusion and the issues people are having with some of the direct power servos and connecting them to these series harnesses is that they are shorting them. They'll plug them in and the wire on the servo will melt and it'll fry. They don't understand what's happening. That's because of how the power transfers between these lines. So what you have your power, you have a negative, right? Well, when the power comes in, connects to this battery, power flows back out to the next battery. This is not a negative. Over here on this side, this is not a negative. This is a continued power. So if you take one of our inline connectors, which is this, quick pause, an inline connector is for direct power servos, so you can tap in between your ESC and a battery. This allows you to get power without having to solder. You simply plug it in here. You'd have your battery. I know this has a different connector on it, but you get the picture. You get your battery and you plug it into this side of the connector. Right, now you have two power taps. Direct power servo. You have your JST power tap and your receiver plug. The receiver plug is going to go to your receiver. Your JST power tap is going to connect to the power tap on the inline connector. Real simple, makes it plug and play. The problem, like we were saying, is this is no longer a ground. You look at these JST wires, one side positive, one side is ground, right? So you got power coming from the ESC, power. So on this side of the plug, that's our power side where these are connected in here. The other side needs a ground. Well, this side is not a ground. This is a continued power. Goes in the battery power, comes out the battery power, is going to the next battery. This side actually has a solid ground and a power. So you cannot connect these inline connectors on this side. You cannot connect them on this power side. This side has to be connected only to your battery, or if you are going to use one of their jumpers, just to continue the power over, that's fine. You can use your jumper. The inline connector has to go on the side with a dedicated ground. This way, plug it in. Looking at our wires again. Power, it's got power. Ground, it's got ground. This, you will have no issue. You plug it in. You got power there. This connects to your receiver, right? This is the ESC connected to a small little receiver. This is the receiver plug for the servo. This is the power tap for the servo. Plug this guy in. None of this has power right now, so it's not like it's going to turn on, but that's all there is to it. You plug in, you're done. You just have to connect these to the right side when using it on an ESC that has these hardwired series connections, right? Now, for those who are running higher voltages, actually real quick, just to help make it clear on why this shorts out when you run it on the wrong side. When you run it on the wrong side, obviously, like I said, you have two powers. It's not a ground. So you're connecting this, which is supposed to be a ground, to the servo. On a servo, like we've said, you have your power cable and you have your receiver cable. These both share a single ground connection on the PCB, also known as the controller, the board inside the servo. They share the same ground, right? So with your receiver, you have the ESC's plug coming from the ESC, which has a ground and a power. So this ground, which is a solid ground coming from the main power source, is connected to your receiver. You have the plug from your servo, which is shared by your power source plug. Same ground. You connect it to your receiver as well, right? Now they're on the same ground. The receiver has a solid ground from the ESC. Well, this same ground that you're connecting to right here is going back to the servo and is connected to this connection. So if you're putting this ground on a continued power, power and ground makes a short. That's where it's going on. You're frying the wire right there. That's why that happens. That's where the short is. So even if you're only running one battery on here, like I said, you have a continued or a jumper on one side, you only have one battery here and you've got this here, you're shorting right here. Power to a ground. The ground is shared by the constant ground coming from the ESC. Power and ground makes a short. It's that simple. So if you're only running one battery, put the jumper on the power side, or if you're running two batteries, battery on the power side, the inline connector must be on the side with a solid ground from the ESC. Connect your power here. You have no problem. You're good. Now, like I was saying, for those running higher voltages than 4S, so 90% of direct power servos out there are unable to go any higher than 4S, right? 2S, 3S, 4S, that's it. There's some rare single brands out there that have higher voltage, but that doesn't apply. 4S, you cannot go any higher. If you go any higher, you're going to fry your servos or any other electronics that you're connecting to it. So if you have, this is a series connection, so it doubles the voltage. So if you're running two 3S batteries, you're going to be running 6S. If you're running two 4S batteries, you're running 8S. This applies to those with, you know, a Super Baja array, or I believe the SCX6 is actually a parallel connection, not a series, so it doesn't double the voltage, so that doesn't matter. But a lot of the larger fifth scale, DBL, XE, anything that's fifth scale, or actually, you know what? Even the eRevo 2.0, they have a series connection. So if you run two 3S, you're going to run 6S. You can't run 6S with, you know, direct power servos that are limited to 4S voltage. In those instances, everything with the wiring we've gone over is the same. But between your power connector and the servo, you will have to run a voltage limiter. A voltage limiter is exactly what it is, or exactly what it says. It's going to limit the voltage from your ESC and the batteries to the chosen voltage. We make them, we sell them. Not the smallest things in the world, but for amperage, it takes a little bit of size. These are 5 amps. We also have 10 amps for larger setups running 5th scale servos. This will take in up to 30 volts on the 5 amp version. The 10 amp version will take in up to 60 volts, so it can do 12S. This can do 6S. This will plug into your power connection, the tap, and we offer it in 3 different voltages. You can do 8.4 volt, 12.6, and 16.8, so 2S, 3S, 4S. Plug the servo into the limiter, and you're good to go. So if you have 2 3S batteries on here, 2 4S batteries, this will draw that power and limit the voltage. This is a 16.8 amp, so 4S, and put 4S voltage out. You can run different voltages, whatever your preference is. Like we said, we have the 5 amp version and a 10 amp version, but that is something you have to be aware of when running higher voltages. These servos, most 90% of the servos out there can't handle high voltage above 4S, 16.8 volts. So you have to limit that. Everything still applies. Has to come off the ground side of the ESC with these series connections. The only other option you have available if you don't want to run one of the inline connectors, one of these guys, is you can use a solder connection, right? Not everyone likes to solder, not everyone can solder. A lot of people prefer to solder. When running a solder connection, simply solder right at the base, is my preference, of the ESC. Cut off a little bit of the silicone on the wiring, expose the wire, get a solder to JST connection, and you will solder them right in line. Boom, boom. And then use some heat shrink, some liquid tape, if you must, some wire tape, whatever you're able to do to cover them back up once you've done that. And then your servo, direct power, will plug right to that. You don't have to use the inline connector. You're good. But the same issue applies for voltage. Up to 4S, you're fine. If you're above 4S, you will need to run the limiter in between. So this will connect to the solder connection here. Let's tap the ESC, right? Straight to your limiter and to your servo. Limiter only applies for those running 6S, 8S, 12S, higher voltages on larger trucks. Well, also, you know, the X-Max and the E-Revo and some of those Creightons, they run 6S as well. So you will need a limiter if you're choosing to run a direct power servo. Otherwise, you run a BEC power servo and power it right off your ESC. That's a different topic, but this topic was about wiring on these ESCs with the series connections, which is causing people issues with frying, because tapping into this side of the series connection, which is 2 positives, can't do that. You have to go to the side again with the solid ground to the ESC. Connect the servo to that, and you're good. I hope this helps everyone. I know it was long, and hopefully I stated everything clearly so you can understand. If you have any questions, we are always available. Shoot us a message, an email, and we'll get you taken care of. Thanks, guys.